Thank you, Diana. Thank you, Michael. Thank you, BrainMind, for creating such a great, amazing space for innovation in science. Okay, let's see here. Let's move forward here. So, yeah, I'm going to talk today a little bit about a brand new study that's just coming out, really looking at the impact of meditation on the glymphatic system as a potential mechanism for reducing the onset of cognitive decline and potentially of dementia as well. Now, if you didn't sleep so well last night, you may be feeling a little groggy, and by the end of this talk, you'll know why. If you're over 60 and you have a regular sleep-related problem, you may want, at the end of this talk, be motivated to meditate a little bit more. So we now know that the world's population is aging, right? About 10% of the world's population in 2022 was over 65. And by 2050, we're going to have 1.6 billion people over 65. We've talked about this already. The world's population is also becoming more demented. By 2050, we're going to increase our number of people in the global population by 150% of who have some form of dementia. The world's population is also sleep deprived. Sleep problems are estimated to affect up to 70% of older adults worldwide. So what I'm trying to emphasize here, that there's a really strong relationship between aging and cognitive decline as well as sleep disorders. So together, we think that there is a final common pathway called the glymphatic system, which mediates this relationship. So in 2012, the Danish cell biologist, Mike Nedergaard, was able to use two-photon imaging in mice to track the movement of fluorescent tracers injected into the CSF, and you can see that here. And what she found was that there were three kinds of systems that were working together to move neurofluids throughout the brain. The first system was indicated here, you can see, was the influx of cerebrospinal fluid that comes in through the brain into the, following the perivascular spaces that are coming through the penetrating arteries. The next one was the exchange of fluids, the interstitial fluids, with around the brain parenchyma, bathing the brain with nutrients and reducing all the metabolic waste, getting all the gunk out of the system. And then an efflux of that interstitial fluid down the perivascular spaces outside the vein and into the rest of the systemic parts of the brain and into the body. So there are a number of studies now that show that this system is very active during sleep and not as much during wake. We know that the interstitial spaces increase by about 60% during sleep, and that they are relatively not active when you're awake. One study that I want to point out here that's really interesting by Nina Fultz, Bob Stickgold, and colleagues showed that this system has a particular frequency. It comes at a particular frequency around 0.05 to 0.08 hertz, and that was very interesting to us, that there's some sort of rhythmicity to the system itself. So that drove us to think about how potentially mindfulness may have a similar kinds of effect to modulating these neurofluids similar to sleep. So now we're in year 3 of this study, where we used in vivo MRI methods to assess neurofluid flow around the subarachnoid and perivascular spaces during sleep, meditation, and paced breathing. We focus on the focused attention meditation practice and the salience network, which is shown to be impacted by this particular style of meditation practice. I will say we had 4 different groups. One was a reproducibility control, which is really just being scanned twice. We used a slowed breathing control, which was really important because meditators, when they meditate, they slow their breathing down. We wanted to be sure that it wasn't just the breathing. The meditators had about 2,100 hours of formal meditation practice time, which is about 10 years, translates to about 10 years of meditation practice, about 4 hours a week. So they were adepts. And then we looked at people who were awake, sleep-deprived, and during sleep, and during sleep-deprived wake states. And what we found was that, number one, meditators and non-meditators had significant differences. That there was a strong decrease in the absolute CSF flow through the cerebral aqueduct. And that's how we can measure some of the changes in the flow states. That was not, it was directionally similar to the sleep changes that we saw as well, and you didn't see that in the other control groups. We also saw CSF velocity changes, specifically in the meditating group, so suggesting again that there's more efficient net flow during meditation. And we saw the same kind of rhythmicity, right, in the fourth ventricle and the spinal column. That was around the same kind of frequency that we saw that's been shown in sleep. We also showed anti-correlations in the salience network with CSF flow, suggesting that the more activity you see in the salience network, the more you saw this effect being impacted by CSF flow. And lastly, we saw more experienced meditators show greater decreased changes in CSF flow from baseline to meditation. So all of the data is suggesting that meditation is good for your glymphatic system, similarly to sleep, and opposite to that observed with increasing age and neurodegeneration. And despite the overall reduction in CSF flow, there's an increase in the fourth ventricle and perispinal spaces with a rhythmicity. And that's very interesting that there's a rhythmic nature to it, which has been shown now you can stimulate the brain in that particular rhythm and entrain it to also activate the glymphatic system. So it's not just meditation, but you can do some form of stimulation to do that. Okay, so I just want to say thank you to my collaborators, Manus Donahue, and our research lab at Vanderbilt, and thank you all for listening.